grade 12, we're going to do 5.6 today, solving logarithmic and exponential equations. Okay, so there's three types we're going to do. The first type is an equation where you solve for x. Log equation, where you solve for x. Something that might look like this. You might get log 3, log 3, 5, plus log 6, 3, 4, equal to log 3x. So what we're going to have to do is we're going to have to use the log laws that we use. So right here I see that we have addition. That tells me I'm using the product law. So this is the same as log 3, 5 times 4 is equal to log 3x. Therefore, I can say, since these are both logged to the same base, I can say 5 times 4 is equal to x, or in other words, 20 is equal to x. Okay? Let's do a more complicated one. Here, I'm going to do this question two ways. Log 3x minus log 3 log base 3 of 4 to 2. So here I see subtraction. That tells me I'm using the quotient property. I know that this is going to be the same as log 3x over 4 is equal to 2. Now I say, oh geez, what do I do? If you remember, the definition of a logarithm is that this means that 3 to the power of 2 is equal to x over 4. 3 to the power of this guy is equal to that. Okay? So now it's just algebra. I have 9 equals x over 4. X is equal to 36. And what I should have done before was important is subbing this in. Does that make sense in your calculator? Is that, if I sub in 36, do I get log 3, 36 minus log 3, 4 equal to 2. And there's a couple things you could do. You could sub it in your calculator, and you can check that out. Well, let's use log laws. Log 3, 36 divided by 4 equals 2. What does log 3 of 9 equal to? Just 3 to the power of 2 equals 9? You betcha. Okay, I'll show you another way I could have solved this one. I could have said that this is the same as, whoops, let's go back to that. This is the same as log 3 x over 4 equals 2. And what I could have done is I could have said, Kate, I need to write 2 as a base 3. Well, 3 to the power of 2 is 9, so I know that this is the same as log 3, 9, because 3 to the power of 2 is 9, equals log 3 x minus x over 4 rather. And since these have the same bases, I can therefore say that x over 4 is equal to 9 and x equals 36. And we already checked that, so we know that to be true. Okay, let's try a more complicated one. Log 6 x minus 3 plus log 6 x plus 2 equals to 1. Okay, first thing I'm going to notice is that there's addition. That means I'm using the product rule. Of x minus 3 times x plus 2 equal to 1. Okay, so using the definition of the logarithm, I know that 6 to the power of 1 is equal to this jump. So 6 to the power of 1 is equal to x minus 3, x plus 2. Well, guess what? I'm going to expand that. That's x squared minus 3x plus 2x minus 6 is equal to 6. Get 0 to one side. X squared minus 3x plus 2x is going to be minus x. Negative 6 minus another 6 is minus 12. Can that be factored? Can that be solved in some way? Here we have x minus 4, x plus 3. Therefore, x equals 4 and x equals negative 3. Now this is where checking comes into play. So the number 4, let's check that first. Log 6, 4. 4 minus 3, sorry, is 1. So log 6 of 1 plus 4 plus 2 is 6 equal to 1. Well, what is log 6, 1? 6 to the power of what gives me 1? 0. Okay. And 6 to the power of what gives me 6? 1. So does 1 plus 1 equal 1? You better believe it. Okay. Now let's try checking out. Remember, this is x minus 3, and this is x plus 3. Okay, so this one, check, works. X minus 3. You guys can probably guess by the way I was talking that this one isn't going to work. What's minus 3 minus 3? Negative 6. Okay, negative 3 plus 2 is minus 1. 6 to the power of what gives me negative 6? Absolutely nothing. There's no such thing as a negative logarithm. There's no negative logarithm. So by definition, no log of a negative number, let's write it that way. Log of a negative number does not exist. I'm just logging. Okay. Right next. B. Okay, so that was case 1. Case 1 is we are doing. No, not going to work, computer. Case 1, we are logarithmic equations. We're solving for x. Case B, I guess we're doing here. Case B is two numbers are logarithms. Then the numbers. Okay. If the logarithms of two numbers written in the same base are equal, then the numbers must also be equal. So let's look at a case here. So if I have log x is equal to 2 log 5, okay, then I can say, using my log rule, I can say log x is equal to, well, this is that power rule, is equal to log 5 squared. Log x is equal to log 25. Well, guess what? Same bases, I can say x equals 25. Okay, try another one. A little more. Log 3, 2x minus 1 is equal to log 3, x plus 7. Okay, so I said, well, these are both the same base. I can therefore say 2x minus 1 is equal to x plus 7. Guess what? I can bring x's over, I don't have x here, x equals 8. Okay, let's do more. Log x plus 3 minus log 2 equals 2 log x. So these all have the same base. Even if I would have the number 7 there or something, they would all have the same base. When there's no number written, do you guys know what base it is assigned to? It's actually assumed to base 10. There you go. Okay. So this was log 2. I erased him. Okay, let's try this one. Here I have subtracting, so using log laws. I know that this is the same as x plus 3 divided by 2, which is equal to log tell me this is log x squared. Because I have the same base, I can say x plus 3 divided by 2 is equal to x squared. Cross multiplying, I can get 2x squared is equal to x plus 3. Bringing everything to one side, 2x squared minus x minus 3 is equal to 0. I'm going to try and factor this. I'm going to get 2x minus 3 times x plus 1. I have that x equals 3 halves and x equals negative 1. This one's going to work. This one we're going to reject. Why do we reject that one? Because if I were to sub this in, here's my problem. I get log 2 times log of negative 1. So 10 to the power of what gives me negative 1? Absolutely nothing. There's no such number. So that's why we have to reject that. Okay, last case. C is when we have no common base. And we're going to use this is the true reason why we use logarithms even though we have calculators, okay? This is why we teach logarithms. So for instance, if I told you to solve 2x equals 10, what we're going to do is we are going to take the log of both sides. We're going to say log 2x is equal to log 10. Okay? Then this due to the power law, I can write it as x log 2 equal to log 10. Okay, and then I can say x is equal to log 10 divided by log 2. Okay, and this is actually the change of base formula. So Logan and Cody are going to say, oh, well, that's just the same as log 2, 10. So make a note to yourself, change of base formula. I think we learned about that in 5.4. So this would be x equals, this would be the best answer. Okay, I think in the textbook sometimes it says do it to a couple decimal places, so you can either enter in this or that. Enter it to 5 decimal places, it would be 3.3219. Okay. Let's try another one. No, not going to work. There we go. Okay. Something more difficult. Let's go. 4. No, doesn't work. There we go. 4 to 3x equals 35. I'm going to take the logarithm of both sides. Log 4 3x equals to the log of 35. Again, we're doing it to base 10 here. Using those logs, I can say 3x log 4 is equal to log 35. 3x is equal to log 35 divided by log 4. Okay, and now I want to get x entirely by itself. So I'm going to divide by 3, both sides divided by 3. Okay. So this would be 3 log 4 is the same as log 4 cubed. 4 times 4 times 4. This is a change of base formula. That is the same as log 4 cubed. I don't know what 4 cubed is off the top of my head. 4 times 4 is 16. 16 times 4. I'm sure one of you shouted it out already. It's 24. 64, I believe. So log 64. 35. That would be your most precise answer. Putting that in your decimal, putting in your calculator and getting a decimal should be 0.8548. Okay. Last example for you guys. There we go. 3, 5 to the 2x minus 6 is equal to 2x plus 7 over 7 to the power of x. first thing we're going to do is we're going to take the log of both sides. So it's like just putting a log here and a big log here. Okay, so I see something's multiplied and divided. That's going to tell me I'm using my log laws. So the product rule tells me that this is the same as log 3 plus log 5 to the power of 2x minus 6. This is the same as, because we're dividing, as log 2x plus 7 minus, I'm dividing, log 7x. Now I have some powers going on. Log 3 is going to stay the same here, plus 2x minus 6 times log 5 is equal to x plus 7. Bring that forward, log 2 minus x times log 7. Okay, I'm going to do some distributing. Log 3 plus 2x log 5 minus 6 log 5 is equal to x times log 2 plus 7 log 2 minus x log 7. And I'm going to bring all the x's to one side, anything with an x to one side, so here's an x, there's an x, there's an x. I'm going to bring them all to this side. I have 2x log 5 minus x log 2 minus x log 7 is equal to 7 log 2 minus log 3 plus 6 log 5. Okay, now I'm going to factor out my x here. If I factor out an x, I'm left with 2 log 5 minus log 2 minus log 7. 7 log 2 minus 3 log 3 plus 6 log 5. Okay, I want x by itself, so I'm going to divide both sides by this thing. So I have 7 log 2 minus 3 log 3 plus 6 log 5. So we're just doing algebra now. Divided by 2 log 5 minus log 2 minus log 7. And this is where we're going to use our calculator, because all of these things, each of these terms, they are just numbers. Like if you put them in your calculator, you're going to get something else. So, or something else is what I meant. So what I want you to do is I want you to press pause. Uh-oh. I think I have a plus when I should have a minus. Let's look at this log 7. X log 7. So I was subtracting it here, so I should have been adding it here. Okay, one mistake from this cancel out. Other than that, looks good. Okay, so what I'm going to do is I'm going to put this in my calculator. You might want to put major brackets. You might want to do each term separately. The most you can put in your calculator, the better, though. It kind of makes it a little easier. So press pause, calculate this out. Press go only when you guys are ready to check the answer. Okay, I'm hoping you all checked your answer. You all checked with one another. You should get 2.9989. Okay, you guys have all you need to do. You're doing questions 1 to 31 odd in this section. It's a lot of computation. You guys will do really well. Good luck.